guys.
How are you feeling?
Been better.
God, what you did was kind of an example of a vector.
Wouldn't it be a scalar?
What's the difference?
Well, vector is direction, and scalar is just a number. But how have vector forces been represented in class lately?
Well, with those trail problems, because you can use them to find someone who's been lost.
Oh, yeah.
But I don't understand how vectors can be added graphically and mathematically.
Well, graphically, you can make a drawing that's drawn to scale, and then you can find out the velocity from that. Or, using math, you can use trig functions such as sine and cosine to find out the velocities. But what does it mean when people say the horizontal component is independent to the vertical component?
Well, it's because they have different velocities. But can you explain how a vector is resolved into its components?
Well, the vertical velocity is found by taking the sine of the angle and multiplying it times the initial velocity. For the horizontal velocity, it's the same thing, except you use the cosine instead. But what is an equilibriant?
It's the force equal to the opposite sum of the resultant sum of the vector forces. But let's say a ball is thrown into the air at a random angle. What is the motion in terms of its vertical and horizontal velocity from the time it is thrown to the time it hits the ground?
Well, the horizontal velocity is constant through the whole thing, but the vertical velocity decreases until it reaches the peak height, and then increases on the way down until it's stopped by a force. In this case, it would be a glove. But explain how an angle launch affects the horizontal and vertical velocities and displacements. At what angle will a thrown ball have the largest displacement?
Well, first, 45 degrees will give an object the biggest displacement. Also, if an angle is less than 45 degrees, its horizontal velocity will be greater than its vertical, and vice versa after angles that are greater than 45 degrees. Wow, that was really cool.
I totally understand.
Now I know so much about projectile motion and vectors.
Well, now you should fall off the balcony.
I don't think so. We're not going to be partying again for a really long
I know.
time.
Hangovers.